Today in the workshop, we're working with ESP-NOW. We'll see how we can use ESP-NOW to send data between ESP32 and ESP8266 boards without Wi-Fi or a router. We'll also build a remote temperature monitor with multiple sensors. We're talking amongst ourselves today, so welcome to the workshop. Well, hello and welcome to the workshop, and today we are going to be working with ESP-NOW. ESP-NOW is a protocol that was developed by Espressif for use with the ESP32 and the ESP8266 boards. All of these boards have a 2.4 GHz transceiver, and they use it for Wi-Fi and Bluetooth purposes, but they can also use it for other purposes, and that's where ESP-NOW comes in. With ESP-NOW, these boards will be able to talk to one another and exchange data without the need of a Wi-Fi network, so it can work anywhere. You don't need a router or anything to make this work. You can exchange data in one direction, i.e. unidirectional. You can do it bidirectionally, and you can have more than one device and create your own small little network of devices. Now, this uses a transmission standard that is similar to that used with wireless keyboards and wireless mice. And so one restriction here is we can't send great volumes of data. We're only going to be able to send packets that have at the most 250 bytes in them. So if you want to send something like video or audio, you're going to have to find a way of getting all of that into small packets and disassembling it on the other end. What this is actually really good for is things like remote transmitters and remote sensors that we want to use. And indeed, we're going to build a remote sensor system a little later on in this video. But first, we're going to start off by learning a little bit more about what ESP-NOW is. ESP-NOW is a communications protocol developed by Espressif. It allows for simple communications between ESP devices. These are short packet transmissions in the 2.4 GHz band. You don't require any Wi-Fi to use ESP-NOW, you don't require a license, and the transmissions can be either encrypted or unencrypted. ESP-NOW devices can be used in unidirectional and bidirectional modes. This connectionless protocol provides a persistent connection after pairing, meaning that after you pair two devices, they'll instantly pair again when they're powered up. ESP-NOW works with both the ESP32 and the ESP8266. Devices can generally be used reliably within 100 meters, and there's now a long-range mode that allows up to 480 meters between devices. The simplest ESP-NOW configuration is one-way communication. In this configuration, we have one device which acts as an initiator and another device which is the responder. The initiator sends data to the responder. We can also have a configuration with one initiator and multiple responders. The initiator can send data to any of the responder devices. Conversely, we can also have a configuration with one responder and multiple initiators. In this configuration, any of the initiators can send data to the responder. This is a common configuration for data acquisition. The ESP protocol is also capable of two-way communications. During two-way communications, each device is both an initiator and a responder. You can also arrange two-way devices within a network. Again, each device will be both an initiator and responder and can have two-way communications with any of the other devices. You can mix and match ESP32 and ESP8266 models inside an ESP-NOW network. The biggest limitation of ESP-NOW is that it is packet transmission, and you are limited to a maximum of 250 bytes per packet, so you won't be using this to send audio and video, but it's great for sensor data. You can have from 6 to 20 stations depending upon which mode you've selected, and also depending upon which devices you've used encryption upon. In order for an initiator to send to a responder, it requires the responder's MAC address. MAC is an abbreviation for Media Access Control. A MAC address is a 6-digit hexadecimal number. Every network device has a unique MAC address. A special MAC address of all Fs is the broadcast MAC address. While the ESP-NOW protocol does not actually support broadcasting, it does support a pseudo-broadcast mode. This mode allows you to broadcast information to every device in the network simultaneously. When using ESP-NOW in our programming, we make use of callbacks, which are functions that are called during sending and receiving. During sending, we make use of the ESP-NOW register send CB callback. This is called when data is sent. It'll return the status of the sent data as well as the status of the received data. On receive, we use the ESP-NOW register RCV CB callback. This is called when the data is received, and it returns the actual data inside the packet. When writing a sketch to send with ESP-NOW, we first initialize the ESP-NOW library. We then register a callback function that we'll use upon sending data. We'll then add a peer device. The peer device will be the responder's MAC address. We can then send our message to the peer device. To write code for the receive side, we'll initialize the ESP-NOW library. Then we'll register a callback function that we'll use upon receiving data. And within that callback function, we'll write some code to save the message to a variable so that we can use it. The ESP-NOW protocol has several applications, including data acquisition, remote monitoring, IoT applications, alarm systems, and remote controls. So let's put ESP-NOW to use in our projects. So now that we've learned a little bit about ESP-NOW, it's time to start experimenting with it. And so you're going to need a couple of ESP32 boards. I'd say at least 3 of them to do all of the experiments that we're doing today. They don't have to be the same type of ESP32 board. You could also use an ESP8866, but you'll have to slightly modify my code for that because it uses a different Wi-Fi library. Now, one thing you're going to need to know about your boards is the MAC, or media access control address of them, because we'll be using that within our code. And so right now what I want to show you is a very simple sketch you can run in order to get the MAC address off of your ESP32 board. So here's the sketch that we're going to be using to determine our media access control, or MAC address, on our ESP32. And it's an extremely simple sketch. We just start off by including the Wi-Fi library, and then we go into the setup where we're running everything. And in setup, we start off our serial monitor. We put the ESP32 into station mode, and then we print out its MAC address. It's as simple as that. And then we end the setup and the sketch is over. There's nothing in the loop. And so what we'll do is we'll load it up to an ESP32. We'll open up our serial monitor. We'll probably have to press reset because by the time we get to our serial monitor, the sketch will have already run once. And we can determine what the MAC address of the ESP32 is. Okay, I'm ready to upload my MAC address sketch to an ESP32. Now I have a number of ESP32s over here, including one that I've connected to the computer and that's flashing right now a very colorful routine, because this is a brand new ESP32 just taken out of the box, and so this is a multicolored version of the Blink sketch that it's running. This is an ESP32S dev kit board, by the way. And I've got a few other ESP32s, different types of ESP32s over here, and you'll notice I've got a label on each one of those, and I'm doing that so I can keep track of my MAC addresses, and I'll show you that in a bit. But first let's go back to the Arduino IDE and let's upload our sketch to the ESP32 board. Okay, and our sketch appears to be uploaded. Now let's open up our serial monitor, and chances are we aren't going to get anything. What we're going to need to do is we're going to need to reset this board. And there we go, and here's our MAC address, and as you can see I've got the MAC address. So what I can do is I can copy that, and I can go over to a spreadsheet I made, and I'll just drop that into there and give this a name. That tells me what I need to select in the Arduino IDE. So I'm just keeping a spreadsheet of the MAC addresses so I can use them while I'm experimenting with ESP-NOW. So now that we know the MAC address of our boards, it's time to start working with them in ESP-NOW. Now our first ESP-NOW experiment is very basic, as it should be, just to let you know how everything works. We're going to set one board up as the initiator, the other board is going to be the responder, and we're going to send data from the initiator to the responder and look at it on our serial monitor. Now there's no hookup for the boards, we're just going to be using the ESP32 boards as they are, and again you can use two different types of ESP32 boards if you want to. So let's go and take a look at the sketch that we're going to use on both the transmitter and the receiver for our basic ESP-NOW demonstration. So here's the sketch that we're going to use on the transmitter ESP32 in our demonstration. Now neither of the ESP32s require any additional parts, but they do require a different sketch. Now in this situation, our transmitter is the initiator and we're going to send data to our responder. We're going to start off by including the libraries we need. We need the ESP-NOW library and the Wi-Fi library. Then we're going to create a couple of variables that we can send over. We're actually going to send 4 types of variables. We're going to send character data, integer data, a floating data, and a Boolean data. Now the character data we're just going to type in later, but the integer, the float, and the Boolean, we're going to create variables for them so that we can change them and make the data appear to be a bit more interesting. After that, we need to set up our broadcast address, which is the MAC address of the responder unit. So you're going to have to run that sketch I showed you to get the MAC address of the other ESP32 and enter it over here. Now these values, of course, will be wrong because these are the values for the ESP32 that I was using. And so you're going to take that 6-element MAC address with the 6 hexadecimal numbers, put the first number over here, the second one over here, the third one over here, etc., and edit that line. Then we're going to define a data structure because we need to send our data as a piece of structured data. And so we define the structure as follows. We're defining a character and we're defining it as A, and we're defining that as an array with up to 32 elements. We'll define the next one as an integer, which is B, the third one is a float, which is C, and the fourth one is a Boolean, D. So these are the types of data that we are going to be sending. And of course, you would modify this for your application to represent the types of data that you need to send. Then we're going to create a structured data object out of that data structure. And so this is our structured data object over here called myData. And we're going to set up some peer information as well. The peer is going to be the responder, and we're going to get to that a little bit later into the setup. Now we define the callback function, and as you remember, there are callback functions used within ESP-NOW. On the sending side, you get a callback whenever a packet has been sent. And so this function will run every time the packet has been sent, and all we're doing is we're going to print up a bit of information onto our serial monitor. Now we'll go into the setup, and in the setup we're going to set up our serial monitor. When we're going to start the ESP32 as a Wi-Fi station, and this is normally how you begin everything before you initialize ESP-NOW. Then we're going to go and initialize ESP-NOW over here, and assuming that we were successful, we're going to register our callback. So we had a function called onDataSent that we're going to use for callback. We're going to register that as being the function that is called whenever the data has been sent. Then we're going to register the peer, the responder in this particular case. So this does this over here, and now we're all set to go. Now in the loop, we're going to create our test data. So for our integer value, we're going to generate a random integer between 1 and 20. And you can change that number there if you want to make it a larger range of numbers. After that, we'll take that integer and we'll turn it into a float to make our floating value. So we're going to just multiply 1.3 by that integer to give us a floating number. And once again, you can change this if you like to another number. It certainly doesn't have to be 1.3. And for the Boolean, since it can only represent 2 different values, either true or false, we're just going to invert it. So as we run the loop, it's going to flip between true and false. Now we're going to format our structured data. So we're going to add everything to the structured data. We copy this into the array over here. Now here's the text we're going to use for our character data. Welcome to the workshop. Obviously you can change that if you wish. And then B, C, and D, which are the integer, the float, and the Boolean respectively, are going to be assigned to the values that we just created above. Then we're going to actually send the message. So here's how you send the message using ESP-NOW. And we're going to see if the results are okay. If they're all right, we'll do sending confirmed. Otherwise, we'll print sending error. We're going to delay 2 seconds and go up and do the whole loop again. So every 2 seconds, we should send some data that's going to include our string over here, our character data. It's going to include an integer, a float, and a Boolean. And so let's go and see what we need to do now on the receiver side. Now here's a sketch we're going to run on the receive side of our ESP-NOW demonstration. And so you'll load this onto the other ESP32 device. We'll start off by including the same libraries as we did in the transmit, the ESP-NOW and the Wi-Fi library, and we'll define a data structure again, and this needs to be the same structure as we used in transmit. So here we are, a structure that has a character, an integer, a float, and a Boolean, and we create a structured data object just as we did before. Now we look at the callback function, and the callback function in this case is going to be called every time the data is received, and this is actually the heart of the whole sketch because it's going to just work by using this callback function. And so every time the data is received, we're going to print out data received and then the length of the data. And then we're going to print the character value and then mydata.a, which will be the character value that we've sent from the other side, the integer value, which is mydata.b, the float value, mydata.c, and the Boolean value, which is mydata.d. And so every time we receive something, this will print up on the serial monitor. Now we'll go into the setup and we'll set up our serial monitor. We start the ESP32 as a Wi-Fi station again, and we initialize ESP-NOW. And assuming ESP-NOW is initialized, all we need to do is to register our callback function. So we register it to that function I just showed you, which is on data receive. And that's basically it. There's nothing to go into the loop because it's going to be the callback function that prints up data to our serial monitor. So let's load this onto another ESP32, put both of them together, and watch our demonstration in action. And so here's our first ESP-NOW demonstration. I've got my two ESP32 boards over here. The board on this side is my initiator or transmitter, and the board on this side is my responder or receiver. And of course, I've got my boards labeled as I showed you earlier so I could record my MAC addresses, and so the transmitter has the MAC address of the receiver in its code. Now if we go up and look at the serial monitors, we've got two serial monitors open. The one on the left side is the transmitter, and the one on the right side is the receiver. And you can open up two different serial monitors simultaneously by opening a second instance of the Arduino IDE and setting the first one to one of the COM ports and the second one to the other COM port. So as you can see on the sending side, it's confirming that it's delivered a delivery success. And on this side, we're seeing the data. We're seeing the four different structures we have. Now, we've got the data received 44 is the number of characters we're getting. And then the character value is welcome to the workshop. That never changes. The integer value, you'll notice, is changing every time because it's using a random number. And the float value is also changing because we're multiplying a float value by that integer value. And the Boolean value on every second one will differ. So it's going to be 0, the next one's 1, the next one's 0, the next one's 1, etc. And so it's a pretty basic demonstration, but it shows you how you can send data of all different types using ESP-NOW. So in our previous demonstration, we just had two ESP32 boards. One of them was a responder, the other one was the initiator, and the initiator would constantly send data to the responder. So this was a unidirectional transmission system. It only worked in one way. But you can also use the ESP-NOW protocol bidirectionally, in which case each board becomes both a responder and an initiator. Another thing you can do with ESP-NOW is use a broadcast mode, which is technically a a pseudo broadcast mode, but it works the same way. And what this is that the ESP-NOW can broadcast to a number of ESP-NOWs simultaneously. What we're going to do in this demonstration is demonstrate both bidirectional communications and broadcast mode. We're going to set up a few ESP32 boards. I'm going to use 3 of them, but you could use 4 or 5 if you want. And every board is going to have a push button and an LED wired to it. And the push button is going to toggle the LED on and off, not only on our own board, but on every other board in the network. So you can control every board's LED with every board's push button, so to speak, if that makes some sense. So let's go and see how we hook the boards up, and then we'll take a look at the sketch we're going to run in each one to demonstrate broadcast mode for ESP-NOW. Now for our network experiments, we're going to require more than one ESP32 module hookup. I'm going to show you the wiring of one of them, but you're going to want to make at least 2 and preferably 3 or more of these setups. You don't have to use the same ESP32 module. In addition to the ESP32 module that you choose to use, you're also going to require a momentary contact push button switch, normally open. An LED, you can use any color you want, and you don't have to use the same color LED for every one of your hookups. And a dropping resistor. I used 150 ohms, but any value from 100 to 220 ohms should work just fine. We'll begin by hooking one side of our switch to GPIO pin number 5. The other side of our switch will be connected to one of the ESP32's grounds. ESP32 pin GPIO 15 is going to go to one side of our dropping resistor, and the other side of the dropping resistor will go to the anode of our LED. And finally, we'll tie the cathode of the LED to ground. And this completes the wiring, but remember, you need to wire up at least 2 and preferably 3 of these boards before we can continue our experiments. Now here's the sketch that we're going to be using for our broadcast mode demo, and you'll need to run this sketch on every one of the ESP32s that you have participating in the broadcast mode experiment. Now we're going to start off by including the libraries we require, the Wi-Fi library and the ESP-NOW library, and then we define a couple of booleans, and these booleans just define the state of both the push button and of the LED. Then we define the GPIO pins that we're connecting those push buttons and LEDs to, so if for some reason you wanted to wire it up differently, you could just change these numbers over here. After that, we have a number of functions that we're going to be calling while we're running our sketch, and the first one is called format MAC address, and from its name, as you can suspect, it just simply formats a MAC address correctly, and we're going to be using that during both the send and receive just to print the MAC address of the machine we're communicating with up on our serial monitor. Then we have the first of our callback functions, and here's the receive callback function. And so this is the function that will be called every time that data is received. And what we do is we basically check the quality of the data. We make sure that it's no more than 250 characters and that it's terminated by a null. And assuming it's good data, we'll grab the MAC address and send it out to the serial monitor just to let you know who it is we're communicating with. And then we'll check the status of the message that's come in, and the message is going to be either simply on or off. And if it's on, we're going to set the boolean for the LED to be true, otherwise we'll set it false, and then we're going to write that to the LED. So in the receive callback, we essentially just grab the data, check to see what it is, and turn on or off the LED accordingly. Now this is the send callback over here, and this is called whenever data is sent. There's not much to do over here. We're basically grabbing the MAC address of who we've been sending packets to and printing that up onto our serial monitor. Then we have a function called broadcast, and this is the function we're going to call every time we want to broadcast a message out to everybody, and we're just going to be broadcasting out a string. And so basically we'll call out the broadcast address, we'll get some peer information, and we'll set up and we'll send out our message, and then we will print the results of what we get, whether it's successful or an error, out to our serial monitor. Okay, so now that we've seen the functions involved, let's look at the actual sketch itself. Here in the setup, we're going to set up that serial monitor. We start off our ESP32 in station mode, and that's just a temporary thing like we always do. We'll print out our own MAC address for our own amusement to the serial monitor. We'll disconnect from the Wi-Fi, and now we'll go and initialize the ESP32 now. If it does successfully initialize, then we're going to register both our receive and our send callback functions over here. If it doesn't register, we're going to print out a message to our serial monitor and just basically restart the entire thing. And then the only other things we do in the setup is define the pin modes of our GPIO pins, and the one for the LED for the push button, is an input, and it's using the built-in pull-up resistor because we didn't wire a pull-up resistor to the ESP32. And then the output is set, the GPIO for the LED is set as an output, and that's for our status LED. Okay, now we go into the loop. We check the status button, and if the button has been pressed down, we're going to need to toggle the LED state. So whatever it was before, we're going to make it the opposite right now and write to our own LED accordingly. And then we're going to check to see what we need to broadcast to everyone. And if it's LED on, if that's what the state is now, then we're going to broadcast the word on, else we're going to broadcast the word off. And then we put in a slight delay as a debouncing. It's actually about a ½ second delay, so you're going to want to press your switch down for a reasonable amount of time. And that's it. Otherwise, the button state goes back to false, and that's just an else from the very top over here where we first pushed the button. And so that's basically the code that we're going to be using. Again, you're going to need to load that onto every one of the ESP32s that participates in the experiment. So I'm going to do that right now, and we'll run it and see what happens. So here's our broadcast mode demonstration. I've got the same code that I just showed you loaded onto 3 different ESP32 modules, and the modules are just being powered by a USB power bank over here. Now, 2 of these modules are identical. They're these 2 over here are the ESP32 WROVER modules, and this is a different module. It's an ESP32S dev kit module, and it might look like I've got it wired differently, but I'm using the same GPIO pins, GPIO 5 and 15. It's just that the pinout of this module is different than the pinouts on these modules over here. And so that's something that you always need to be aware of when you're working with the ESP32, is that you should always follow the wiring diagram's GPIO pins. Don't go by the physical pinout, because the module you're working with may indeed be a different one. But again, these are running the same code, and if I press on a push button on one of them, I can turn off all of the lights, and I can turn them back on, and I can do that from any of them. And we'll try this one here. I can also turn it off with one push button and turn it back on with another one. They're all following the broadcast signal, and they're all just following the signal for the status of the LED and acting accordingly. And I could have more of these boards sitting here doing the same thing as well. And as you can see, they don't all have to be the same type of ESP32 board as well. So there you go, a demonstration of a broadcast mode of ESP-NOW. So now it's time to put our ESP-NOW knowledge into some practical use. And so what we're going to build is we're going to build a remote temperature sensing system. In this system, one of our ESP32s is going to have a DHT22 temperature and humidity sensor on it. And it's going to take that data, it's going to be the initiator, and it's going to send that data over to the responder, which is going to display the data on the serial monitor. So you can have your temperature sensor situated far away from where you're actually displaying it. And this, of course, is a practical application. So let's go and take a look at the wiring for the board that is going to have the DHT22, and then we'll look at the code we need for both the initiator and the responder. For our remote sensing experiment, we're going to require two ESP32s. One of the ESP32s does not require any additional hardware. However, the other one is going to require a DHT22 temperature and humidity sensor and a 10K pull-up resistor. We'll begin by connecting data input GPIO5 to the data output of the DHT22. We'll connect the ESP32's 3.3 volt output to the VCC pin on the DHT22, and the ESP32's ground will be connected to the DHT22 ground. Finally, we'll connect our pull-up resistor between the input on GPIO5 and the 3.3 volt output. And this completes our wiring. Now, obviously, if we're using two ESP32 devices for this project, we're going to require two sketches, one for each of them. So this is the sketch for the transmitter device, the one that we wired the DHT22 to. Now, we start off by including our required libraries, which once again are the Wi-Fi and ESP-NOW library, and we'll also include the DHT library. Now, I'm going to assume that you have that installed in your Arduino IDE because we use this sensor so much, but if you don't, you can go into your library manager and look for DHT and install the library. Next, we're going to define the parameters of the DHT22 sensor, and so the DHT pin where it's connected is pin 5, and the DHT type, the type of sensor we have is a DHT22. Now, if you decide to use, let's say, a DHT11, you could change this line over here. Then we create an object that represents our sensor. After that, we define a couple of variables, both of them floats, that represent the temperature and humidity. And we'll also define the responder MAC address. In this situation, we are the initiator and the receiver is going to be the responder. And so you're going to need to get the MAC address of the other ESP32 and insert it over here. Obviously, these numbers aren't going to work for you because these are for my ESP32. Then we define our data structure, and our data structure is going to contain two floats. It's going to contain the temperature and humidity. And then we'll create a structured data object from that structure. We'll register our peer, and now we go to our sent data callback. This is the function that's going to be called every time data is sent. And the only thing we're doing in here is we're going to print out the status and whether the delivery was successful or whether that it failed. Then we'll go into the setup, and it's pretty simple. We're going to start our serial monitor. We'll initiate the DHT22, and we'll set the ESP32 temporarily up to station mode in Wi-Fi, as we always do when we're using ESP-NOW. Then we'll initialize ESP-NOW, and assuming that it initializes correctly, we'll register our callback, the function that we already showed you that is called every time data is sent. And then we're going to register our peer. Our peer in this case is going to be the responder, so assuming everything is correct, we have the peer registered, and we go down into the loop. Now in the loop, we're going to read the DHT22 in the standard fashion and assign its values to the temp and humid variables. Then we're going to print those up to our serial monitor just as a troubleshooting technique. We're going to add them to the structured data object, and then we're going to send that data. So we're going to send those two pieces of data out. We're going to put a 2-second delay in for the DHT22 because that's what it requires to stabilize between readings, and we'll do it all over again. So there you have the transmitter sketch. Now let's go and take a look at the sketch that we're going to be using on the receiver side. Now here's the sketch that we're going to run on the receiver side of our remote sensing system. And remember, the receiver ESP32 does not have any additional hardware connected to it. We're going to start off again by including the required libraries, the Wi-Fi library and the ESP-NOW library. And then we're going to define our structured data type, which is the same one that we defined in the earlier sketch for the transmitter. So we've got two floats in the structured data type, and we'll create the structured data object. Now we define our callback function, and this is really the heart of the entire sketch because the whole thing works on the callback function. Now this callback function will be invoked every time that we receive data, so what we're going to do is get the incoming data and then print some of it out. My data A is going to be the temperature value, and my data B is going to be the humidity value, and so those will be printed out to the serial monitor. Now in the setup, we're going to set up the serial monitor. We start the ESP32 in station mode again. We initialize ESP-NOW, and then we register our callback function, the one that appears every time that we receive data. And that's basically it. There's nothing there in the loop. Every time that callback function is called, it should print out to our serial monitor. So let's load all of our sketches up and give the whole thing a test. So here I have my demonstration of my remote temperature sensing, and in my demo this SparkFun ESP32 thing board is my receiver or my responder, and this board over here, which is an ESP32 dev kit board, is my sender or my initiator. And if we go on to the serial monitor, I've got a serial monitor open on each one, and you can open multiple serial monitors again by just opening a second instance of the Arduino IDE. So over on the right, I've got the initiator, which is sending out temperature and humidity data. And on this side over here, I've got the responder, and it's printing out that temperature and humidity data. And so it seems to be doing that pretty reliably. I'll just clear the output so we can kind of watch it go in sync with each other. It's a little hard to see when there's all this on the screen. And so there you go. You see these are synchronized, and it's sending out the temperature data and the humidity data, and it's receiving it over here. And so we've built a remote temperature receiver using two ESP32s and the power of ESP-NOW. Now earlier on, when I explained the basics of ESP-NOW protocol, I illustrated a system in which we had multiple initiators and one responder. And so we're going to finish off today by doing exactly that with the system that we just built with the remote temperature system. Right now the remote temperature sender is the initiator, and the responder is just displaying the temperature and humidity. But we could build more than one initiator and have it send to the same responder. So that's exactly what we're going to do. We're going to put another ESP32 board together with a DHT22 wired exactly the same way as we did before, and we're going to make some slight modifications to the code so we can use multiple initiators and one responder to make a remote temperature and humidity sensor that can sense temperature and humidity from several different locations. So let's go take a look at the changes to the code we need to make in order to accomplish that. Now here are the modifications we're going to need to make to the transmitter side in order to use multiple devices with our remote sensor system. Now, every transmitter is going to have its own unique number, and that's basically the modifications that we're making over here. So we start everything off the same, but the first thing that we add that's different is this integer that we're adding called a dent, and that's for identifying it. And for every ESP32 that you load this up on, you're going to need to change this integer. Now, I've got this one set to 2. My first one would have been 1. If I have 3 or 4 of them, they'd be 3, 4, etc. So every one that you load this up onto needs a unique identity number. And then the data structure needs to change because we need to send that identity number. So in addition to the 2 floats we had, we now have a third element in our data structure, and that's an integer. And then if we go down over here, we're going to see where we put all of this into use. If we go into the loop where we add to the structured data object, we're going to add the ident into the structured data. So we're going to be transmitting that along with temperature and humidity. And that's really the only modification that you need to make to the transmitter side. Just remember that when you're setting up this ident variable, it has to be a different number for every one of them. So you're going to have to change that every time you upload it to a new board. And now let's take a look at the modifications we need to make to our receiver side. So here are the modifications we're going to need to make to the receiver side of the sketch to allow for multiple transmitters. And there's not too many modifications. You can probably guess what they are too. The first one, of course, is we've got to make our data structure the same as our transmitters. So we're adding a third element, the integer, which will be the identification number of the transmitter. And then what we need to do is we need to go down to the callback function and edit how we print everything to the serial monitor. So we're going to print temp sensor, and then we're going to print the number of the temp sensor. And so we get that from the C part of our structured data. And we're going to print then the temperature data, humidity sensor. Again, we'll print that C part of our data to give us the number of the humidity sensor, and then the actual humidity data itself. So it should print temp sensor 1, the temperature, humidity sensor 1, the temperature, and then when the other one comes along, temp sensor 2, its temperature, the humidity sensor 2, its temperature, etc., etc. So again, some very simple modifications to make for multiple use. Now let's go load these up on our two ESP32 boards and give it a test. And so here's a look at the serial monitor of my running demonstration. And as you can see, I'm getting data from two different temperature sensors. Now, temperature sensor number 2 is one that's right here on my workbench with me. And so it's giving a reasonably temperate temperature of 24 degrees right now. Temperature sensor number 1, I've got sitting in a window right now. And I actually just put it in the window so the temperature will continue to drop, because I think it's actually only about 6 degrees Celsius outside right now, and right now it's reading about 10 degrees there, and it's probably going to continue to drop a little bit as well. And so these two temperature sensors are separated from quite a distance. The one in my window is in a window that's on the far end of my basement, so it's broadcasting from over there, and I'm not having any problem with the range. And so as you can see, I'm able to add multiple temperature sensors to this system, and I could add some more temperature sensors to it as well. So this could be a very practical system if you want to record environmental conditions in different places and have them go back to a central source. And we can do it all without Wi-Fi, just using ESP-NOW. So this concludes our look at ESP-NOW, and I hope that it's shown you that ESP-NOW is a very versatile protocol that you can use for a number of peer-to-peer applications for the ESP32 and the ESP8266. So hopefully it's given you a few ideas for some applications of your own. Now, if you want to get more information about ESP-NOW, or if you want to grab the sketches that I used today, you'll find all of that in the article that accompanies this video on the dronebotworkshop.com website, and of course there is a link right below the video to that article. You'll also find a link to join the newsletter. If you haven't signed up to my newsletter yet, please do so. It's not a sales letter, it's just my way of letting you know what goes on here in the workshop. If you want to discuss ESP-NOW further, the best place to do that by far is the DroneBot Workshop forums, where you'll find thousands of other electronics enthusiasts who'll be happy to discuss anything about the ESP32 or any microcontroller or electronic related matter. And finally, if you have not subscribed to the YouTube channel yet, please do that. I love getting new subscribers, and I'd certainly love to have you be my next one. All you need to do is click on the red subscribe button, and also if you click that little bell notification, and if you have notifications enabled on your YouTube, you'll get notified every time that I make a new video. So until we meet next time, please take good care of yourself, please stay safe, and I will see you again very soon here in the DroneBot Workshop. Goodbye for now.